Are you ready to see some code? I don't have slides. I don't have any slides. I just have code prepared, and we are going to do a deep dive. So what we essentially are going to try in this session is we are going to lift the curtain a little bit and peek behind the scenes. What does GitHub Copilot really do when it suggests some code to you? What does it really do when you answer questions or when you ask questions in the chat window? What happens on the wire when you ask GitHub Copilot to generate tests? This is exactly what we are going to take a look at. So let me make a quick introduction. That's me, Rainer Stropek. I have my own little company which is called Software Architects. We are building software as a service solutions in the Azure cloud. Our flagship product is called Time Cockpit. If you would like to check it out, feel free to do so. If you would like to keep in touch with me, the best way to do so is to link yourself up with me in LinkedIn. If you go to my digital business card, which is rainerstropek.me, you will find some links to social media platforms, also including my YouTube channel, where you will probably see this recording. Just remember this slide and everything will be fine. All the code that I'm going to show you will be available on GitHub. It is available on GitHub at the end. I will show you the link, but to be honest, the code is not that important today because probably we will use GitHub Copilot with your own code. So I'm just writing a little bit of code, a small little game that we're going to build together, but we will not just focus on writing the code and seeing how awesome GitHub Copilot is. We want to peek behind the curtain. For that, I would like to start by reminding you about the architecture that Jürgen presented in the morning. Don't forget, we are here in VSCode. Please use JetBrains-based IDE, use, I don't know, NeoVim, use Visual Studio, use whatever IDE you would like to use. Somewhere deep down, buried in Azure, we have some OpenAI large language models, and here in the middle, we have this GitHub Proxy. This GitHub Copilot Proxy receives the requests from your IDE, does some magic, whatever it does in the details. I don't have the source code, I can't tell you in more details, and this forwards then your requests to Azure OpenAI. There, some answers are generated, and the answers are streamed back from OpenAI to the GitHub Proxy, and then from the GitHub Proxy to Visual Studio Code. And the thing that I am very much interested in today is this communication part here. So what we are essentially going to do, we are going to write a small little game, and we are going to install a MITM Proxy, a man-in-the-middle proxy. So what we are going to do is we are injecting a man-in-the-middle attack to spy on the private APIs and look in details what's going on behind the scenes. This is what we are going to do. So I'm going to use an open source proxy tool which is called MITM Proxy. If you're not familiar with it, don't worry, it's not necessary that you know how MITM Proxy works. Essentially, it's not just a proxy forwarding encrypting traffic, but it's really breaking the SSL, it's terminating the SSL connection. So it's decrypting the code, we are going to see the payload, which is on the wire, and then it's forwarding everything to the GitHub Proxy. So that's essentially what we are going to do in this session. Let me show you the GitHub Proxy, the MITM Proxy. It's already running here. What I essentially did is, don't worry, I will zoom in later on. What I essentially did, I ran the MITM Proxy in Docker. So if I say Docker PS and zoom in a little bit, you see that the MITM Proxy is running here in my Docker container, and it's listening on port 8080. So what I'm going to do a little bit later is I'm going to set up localhost :8080 on my local machine as a proxy in Visual Studio Code so that GitHub Copilot will proxy all requests to its proxy server in the cloud through my MITM Proxy, and then we can spy on the network traffic. Are we good? Are you interested in what's going on behind the scenes? I was too. It took me a while until everything was set up. I will not do an introduction into MITM Proxy, by the way. If you want to know how to set this up on your own, please watch one of the million videos about MITM Proxy on the internet. I'm pretty sure you will find a suitable video. Okay, with that, what are we going to do? I would like to implement, at least partly, a Minesweeper game. Anybody Does anybody who doesn't know what Minesweeper is? Everybody knows what Minesweeper is? Okay, very good. So this is what we are going to do. Let's get started by taking a look at this nice little helper file. So what I did here is I created a helper.js file, and here you see that I have a helper function is opened, which returns true if a certain cell in the Minesweeper game was already opened. You see is marked if I marked something, and now I have a helper function here which is called execute for surrounding cells. What I essentially do is I want to call the callback method that you see here based on a certain coordinate with row and column for all surrounding cells. So I go one to the left, one up, and then I simply call the callback method for the top row, 1, 2, 3, for the middle row, 1, 2, and for the bottom row, 1, 2, 3. Okay, so 8 calls to callback. However, this method should be a little bit more intelligent. What it should essentially do, it should recognize if we are already on the left corner, on the left side of the board, so it shouldn't take the index -1, or it shouldn't go beyond the right border of the board. I think you know what I mean. And now, this is essentially what GitHub Copilot is really very, very good at, right? If we give it a little bit more context, execute the callback function for each surrounding cell. That sounds good. Let's say row call here. And we can also, for instance, say does not execute the callback for the cell itself. Do you see that ghost font? That's GitHub Copilot. You all know what GitHub Copilot is. You all know that this is essentially ChatGPT, what we see here. So this thing can not only support you with writing JavaScript and .NET and Go and Rust, it can write docs for you, it can describe algorithms, it can write tests and so on. It can do all the crazy stuff that ChatGPT is capable of doing. So I don't need to go into the details here. So if I press enter, we can wait a little bit, and hopefully if the network works properly, we should see in a few more moments 2 nested loops. It looks very good. It even recognized that it shouldn't call the callback for the cell itself. Here you see it, and here you see the callback. That's what's going on. Now, usually at that place, I praise GitHub Copilot and say, wow, this thing is so crazy, it saved me just 2 minutes. Yes, we all know that. But today I want to know what's going on. What's happening here? Let's take a look. So what I'm going to do next is I'm going to go into my preferences and settings. Look here for proxy. If you want to do the same thing on your machine, please note that the proxy settings are always user-based. It doesn't make sense to apply workspace-based proxy settings. They are ignored. You have to do it for the entire user. Good, let's do that. Here I can enter the proxy. I will do that. HTTP localhost 8080. See, that is the proxy setting. Now every request that goes from Visual Studio Code outside should go through my proxy. We'll see whether it works. Let's take the proxy, put it here on the right-hand side. Take this one, go here, press enter. We get a suggestion. Activating extensions, everything booting up, and you see here we have it. Here we see something. Let's make this a little bit larger. What you see is some GET requests, as you can see, something with user and so on. And now I'm trying to force it to make a request, and this is exactly what I wanted you to see. This is the request that goes to GitHub, okay? So what you see is we see the request which goes through some blah blah blah, Copilot proxy and so on. And here you see a word which is called codex. I'm not sure if you are all familiar with codex. That's a kind of history lesson. Before we had the GPT large language models, OpenAI had a dedicated model only for writing code. It was called codex. It's no longer used, it's legacy, so still the name is here. It's just kind of, let's say, a reference to the past. Let's put it that way. The interesting stuff that we see is down here. If you zoom in a little bit, we can see some things which are going on. First, the client, my IDE, recognized that we are in JavaScript world. That's fine. it's limiting the response to 500 tokens. I hope you are all familiar with tokens. If not, Google for tokenizer and take a look at the OpenAI tokenizer. It will tell you in very details what tokens essentially are. They are the coin, the currency of the LLMs. You pay for tokens. Essentially, it's typically a short word or a part of a word, or in the context of coding, it's often a mathematical operator or something like this. This is what a token is. So we see that the client tells the server, hey, I only want answers with 500 tokens max. And here you see essentially the prompt. This is what Gerwald told you before. What the IDE does, it's quite smart in generating a prompt for you. Now, if I take a look at this prompt, of course, I would like to play a little bit with that. What we can do in MITM Proxy, we can export the raw request here, for instance, and I will export it to a folder requests slash, let's call it first demo.txt. No, let's call it JSON. Yep. And then I am going to open this folder up. Am I in the wrong? No, I'm in the wrong folder. GitHub something, and open this up in GitHub in Visual Studio Code. And hopefully we will see. I don't need that one. First demo.json. I will get rid of all this stuff here, make this thing a little bit larger. Don't trust you. Yeah, now it worked. See, this is essentially the JSON request, and what I can do now to show you what the whole stuff is all about, I can use a regular expression looking for \n's and replacing it with \n's, and what you essentially see is that the prompt, see, consists of the entire code that we had in the currently open file. It says the path, which is helpers.js. This is the existing code that I already wrote. My cursor is essentially standing exactly here. And here you see another thing, which is the suffix. This is the code that follows after my cursor. So what the IDE does, it's taking your code from the current file, takes it, sends it to the cloud, and takes the code which stands after your cursor, adds it to the suffix here, and sends everything up to GitHub. And then GitHub is using an LLM, OpenAI LLM. In this case, I think, I'm not 100% sure. Maybe the GitHub people can confirm that, but I'm not sure if that's an internal detail. I think it's a GPT 3.5 model, but I'm not 100% sure. I think it's a fine-tuned GPT 3.5, but as I said, I don't have the internals. That's just a guess from an outsider here. So the other thing which is kind of interesting are these settings. If you are deeper into OpenAI, you are probably or maybe familiar with temperature and top P. It's essentially a measure how repeatable, how consistent the responses are versus how creative the responses are. If you want to know the details about these two settings, please take a look in the OpenAI documentation. They have a dedicated chapter on these two settings. It's out of scope for my talk today. Nice, works very well. Now, what came back? Let's take a look at the response. What you see here in the response, which came back from GitHub Copilot Proxy, is a strange looking response. Maybe you would have expected that GitHub Copilot Proxy in the cloud sends back some JSON and that's it. No, it doesn't. What it sends back is a protocol which is called SSE, or Server Sent Events. Just like OpenAI, the OpenAI API, GitHub Copilot internally use SSE, Server Sent Events, to stream the response, the result of the model to the client. The model with code completion, the I think 3.5 model, is so fast that you typically don't see the streaming coming in because everything is delivered very, very quickly. But we will see later on when we use the GitHub Copilot chat that you can really see how the tokens flow from the model through GitHub Copilot onto your computer. So that's another takeaway. It's using server sent events behind the scenes. If you're not familiar with server-sent events and you want to program with OpenAI, for instance, I did a talk recently at a We Are Developer conference. It's online, you can watch it, and I go deep into the SSE protocol, describe how it works, and also how it is used in the context of OpenAI. Just take a look at my LinkedIn profile. You will find a recent post where I link the video. So if SSE is interesting for you, that's exactly what you should take a look at. So we learned something. GitHub Copilot didn't take the entire project, sent everything up to the cloud. It only sent this small little file to the cloud and got a suggestion based on what we see here. And I will simply accept it because this code looks good. It's fine. Check. Got it? Any questions so far? Yes. Exactly. Exactly. It's so fast that you can't see every single line. So let me go here again. What you essentially get is, or the client, what it gets is this line, then a tiny little pause. The HTTP connection is kept open. Then the next stream package will be this. The next stream package will be this, and so on, and so on, and so on. The HTTP response is kept open until the server has generated the entire suggestion. The important thing that you are maybe interested in is something like this. This is part of the code. See? This is two closing parentheses. Somewhere in this code we have two closing parentheses, and this is where you see it in the SSE protocol. Did that answer your question?
Yes.
Yes.
So, but the flow is completely different when I use a chat.
Give me a second. Give me a second. We will take a look at the chat in a few more minutes. Yeah. I would like to have some cliffhangers here. I don't want you to stand up and go now because interesting stuff is coming. Okay, very nice. So we have this helpers.js. I'm super happy with that. So let's open up the index.js because I would like to build a little bit of code together with you. Now, the first thing that I would like to do is I would like, let's do it like that and like that, and make sure that I clean up here, and then I'm giving it a context. I'm saying I want to have a two-dimensional array containing flags indicating whether a cell is a bomb. We are talking about Minesweeper, so we have these comic bombs in the middle of our, you know what I mean. Now if I press enter, we get a response. I type tab. Yes, it's awesome. I probably wouldn't have remembered the array from. I love GitHub Copilot. I don't want to work without it. But we are here to take a look behind the scenes. So, did you note that I opened up two files here? I did that on purpose. That was not by accident. I want to show you what's going to happen if you open multiple files. Okay, so let's take a look. Let's take a look what's going on. Let's take a look at the response, and good, here we are. It's a little bit complicated to see, but what I'm going to do is I will export it again, the request in this case, request, and that is my demo2.txt. Export again. It's requests demo2.txt. Good, here it is. And with that, I open my folder again, and hopefully we will see what we just exported. Yeah, here it is, demo2.txt. I don't want to have all this stuff going on. I just want to have this part, and let me again do the \n with this and replace it so we see the code. And the important thing is, take a look at this one and take a look at this one. This is the important one. See? We had two files open, and what it did take the file helpers.js and add it as a comment on top of the file that we just edited. Again, it takes the other open file, uses a comment operator, and adds it just as if we would have copied it into our current file. So from the viewpoint of GitHub Copilot, it only has a single file. But what it did, it just copies in a little bit of code. And the important thing here is that you cannot rely on this. the GitHub Copilot client takes a look at how large files are. If your current file is pretty large already, it will not additionally copy all the additional open files as comments at the beginning of your code, because that would be too expensive. Again, we are talking about tokens. Microsoft has to run the servers. Those servers are paid, or the costs occur based on tokens, so the input number of tokens and the output number of tokens is limited. If you have a small file, just like I do here, you can rely that other files are copied into this file. But if you have 50 files open and all of them contain thousands of lines of code, don't rely on the fact that everything is just concatenated. This will simply not happen. So the client will limit the amount of code that it sends to the server based on some logic that we don't know. I don't know. You have a question? Very good question. How does it work for company solutions? It doesn't. For complex solutions, it doesn't. It simply doesn't. The tricks that I typically give in non-deep dive codes is you can only rely on the current file. If your current file is small, you can help GitHub Copilot by opening additional files. And that's it. That's all you have. So give me a second. What you can do is you can manually, just like Gerald said, you can manually help GitHub Copilot. So what you can do is, if you know, hey, let's think about C#. You want to build this crazy complex link query. And in order to generate this link query, you need the entity framework data model, but it's in a completely different part of your app. What I really do, and it's not a good solution, but it's the only solution that I know of it works, I do manually what GitHub Copilot does typically for you. I copy the code from the other file, I paste it temporarily in my file, then I generate the link query, and then I remove the whole stuff on top again. Is this beautiful? No. Will it change? I don't know. Ask the GitHub people. They know the priorities of what's going to change. Well, probably it will change at one point in the future, but I'm just here to tell you what the current situation is. It's not perfect, but it's way better than having nothing. And I'm super happy that GitHub published this tool, although it's not perfect, because it's already pretty good. So the answer to your question is, it doesn't, but you can help yourself. At least you have to do it now. Does this answer your question? Maybe it's not the answer that you would have wanted, but it's the answer. So you see, it worked pretty well. And here, again, we see where our cursor stands. We have no suffix because at the end we don't have any additional tokens. And probably the system did correctly suggest us this code. Very, very nice. Okay, good. Now I have a little bit of extra stuff here. Okay, I think this is good. And then we are going to create some cells. Create all cells. So we need to create some cells for our Minesweeper game. I'm waiting for a little bit, and here we have it. We can take a look if it works. I'm not 100% happy, but a small little detail that many often forget is that we get multiple suggestions. We get multiple suggestions here, you see? We have 3 suggestions. Now, if we take a look in what's going on behind the scenes, the last suggestion was this one, and what we essentially get here in the response, you will see somewhere an index. You see it, and if I scroll very, very much down, you will see multiple indexes going on. So the server is streaming multiple versions, multiple suggestions from which you can choose. This is happening behind the scenes. That's a default functionality of the OpenAI API. Let me show you, for those of you who haven't worked with the OpenAI API, let me show you what they are using behind the scenes here. So let's go to platform.openai.com. If we take a look at the API reference and we take a look at the chat endpoint, create chat completions, first, what you see here, I mentioned it before, is the documentation of properties like top P and temperature. Take a look at the documentation if you're interested in. And here you also have a setting which is here, N. So that is already something that OpenAI supports out of the box. You can simply go to OpenAI and say, give me 3 different suggestions. Any questions so far? Good. So let's write a little bit of code, okay? We want to have a loop that goes over all the rows. Let's write it like that. It will wait a little bit. It gets a little bit slower when I'm running the proxy, so don't worry. Typically, it's faster. What I like to use, by the way, is a shortcut which is Control plus cursor right. With that, I can simply accept words. If I know that the rest is not interesting for me, I simply press Control right to accept until I'm happy with it. This is good. Now I want to give it a little bit more context. I simply write the for, and now GitHub Copilot understands, or ChatGPT understands, that, that we can, without any problems, go through the columns. But the important thing here that I want to describe here again, if I write here for space and use the brackets here, the important thing that we see here, let me see if I can show you that. If I scroll down, something here. Yes, this is exactly what I wanted. I would like to point your attention to this and the suffix. GitHub, it's important for GitHub Copilot to support insertions in the middle. In ancient times, when GitHub Copilot came out, it could only add code at the end of the line. But now it has gotten much smarter, because now it understands that there is some code in front and some code in the back, and our cursor is standing in the middle between the two brackets. And GitHub Copilot is perfectly fine generating a little bit of code to be inserted in the middle of the brackets and also after the brackets. So if you take a look at the suggestion that we get here, you see a little bit of code is suggested in the middle of the brackets and a little bit of code is suggested after the brackets. Take a look at the streaming result if you want to know how it does it. But in the request part, it's solved with this suffix thing. I mentioned it before, but this example should really drive it home so you understand why the request is structured as it is. Are we good? Nice, very good. So let call equals something like this. Yes, we are creating an element which is a div. Let me check. Yeah, the class name is okay. We don't need row and column, and we simply add these things. Yeah, append child. That looks pretty good. So let's try it. I'm starting live server or 5 server as somebody might know it, and here is the screen. I already added a little bit of CSS, so we already have some Minesweeper stuff. We simply add a bunch of divs, and using CSS grid, I'm aligning everything fine, so we see something. I think that is good, so let's keep this running in the background. I like that one. Good. The next thing that I would like to do is I would like to place bombs randomly. That is also pretty simple. Let's see what it does. It's going through all the bombs and places it there. I'm not happy with that one. I want to place exactly 15 bombs, but sometimes randomly it might happen that the same index comes up twice. So I would like to steer Copilot in the right direction. So I'm getting in the pilot seat. I'm taking control now and I'm steering it where I want it to have. So I say let bomb count equals 0 while, this is what I do, and now GitHub Copilot understands what I want to do. Got it? It now understands, oh, Rainer doesn't want to have a for loop, he wants to have a different approach. And this is how I typically use GitHub Copilot in real life. I have a plan in my head, I have my class structures, I have my function signatures, I have my algorithms in my head, I'm starting naming variables properly, maybe steering it into the right direction to just write if for or while, and then relying on GitHub Copilot to understand the direction and taking over the control. This is exactly why the product is called Copilot. I am in control. It's not taking away your jobs, it's simply making your jobs easier. And with that, I can simply tab and everything should be fine. What I created up here is a 2-dimensional array where I want to store for each cell in my Minesweeper how many bombs surround this element. Obviously, we have to here do this here. So I need to I don't need to tell you what I have to do, because GitHub Copilot immediately suggests here execute for surrounding cells. Now, execute for surrounding cells is the helper method that we created at the beginning of my talk. Can you remember? That was this callback stuff that goes through the surrounding, and you know what I mean. How did it recognize that this thing even exists? Well, it recognized it because I have this thing open. So you already know the magic. Haha, let's test GitHub Copilot. I will close this file and press enter and see what's going to happen. It still works. Why?
Remember.
No, it didn't cache. Many people think that it cached the answer from before, and now, no, it didn't. It didn't do it. You can take a look at the request. What it still recognizes is that I already added the import statement here. And just based on the name of the import, it recognized, oh, this could be a useful method. I have no idea what it does, but it looks interesting. So I'm going to guess what the parameters would be. Now, let's remove this import statement here, and let's see what GitHub Copilot is going to do. Let's wait, and we get no longer the call to the method. See? And now you understand why this exactly happened. If you open the additional file, it will automatically recognize the method. If you add the import statement at the beginning first, it will automatically recognize this method, but it will not be perfect because it doesn't know which parameter this method has. It will simply guess. And if you don't do anything, it will think that you don't have anything prepared, and it will start either creating everything from scratch, or it starts to hallucinate. That's the other possibility that you have. Okay, are we good? Fine? Okay, I will undo all this stuff. So I will add the import again. I will open the helpers. I will go to index, and here, hopefully, yeah, looks perfectly fine. I didn't have to do anything, just tab, and you already know how this stuff works. Good. Very nice. Now, let's switch gears a little bit and take a look at chat. Are you interested what chat is going to do? Now, I am going to create a function which I call open, and it gets a cell, a row, and a column. And essentially, what I want is I want it to open the cell. It should switch to game over if I happened to open a cell where a bomb is, and it should recursively call the open method if I manage to click on a cell where no bomb is. You know the behavior of Minesweeper? If you click on that, whoo, the whole thing is opening up. You know what I mean. Of course, I could have relied on statement completion, but I don't want to do that. I want to go to the chat window here. So let me clean up our proxy here, and let's ask the system for something. So what I'm going to do is I'm going to mark just these 3 lines of code. You see that? And then I'm asking a question. Can you complete this method for me? Let me show you the prompt so you see it. I know it's a little bit small, but this is what I wrote. Can you complete this method for me? Okay, press enter. A little bit. So here we have the completions. Let's see which is the right one. Yes, exactly. So let's export this request and send it to requests sample, what is the number? I don't know, 3 dot whatever, txt. Okay, let's go to this one, and hopefully we will see sample 3. I will remove all the stuff here, and this is now okay. Let's change everything, and this is now prompt engineering of GitHub Copilot. So this is the prompt that GitHub Copilot is using, and it looks completely different, entirely different from what you have seen before, because these were 2 different products in the past. I see you all reading the text. You are an AI programming assistant. Okay. When asked for your name, you must respond with GitHub Copilot. Okay. Follow the user's requirements carefully and to the letter. Okay. Follow Microsoft content policies. Okay. Avoid content that violates copyrights. I'm good with that. If you're asked to generate content that is harmful, blah, 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 I don't think that I need you to write everything. What you essentially see is you see a limit what the system should do. Have you ever used ChatGPT before? Have you ever written a system prompt before? What the GitHub guys do here is essentially what you do when you use assistant APIs or OpenAI. They are doing prompt engineering. Now this is, as you can see, the system prompt. Those of you who know about the API of OpenAI should already know what the system prompt is. If not, last week I did a session at the tech conference in Vienna. I had a talk about .NET and OpenAI. Take a look at it. I do a lot of details there about system prompts and how you can do it. So let's scroll down a little bit, and you see the next thing is a message with the role user. This is essentially now GitHub Copilot simulating a conversation between you and ChatGPT. This is what you typed in. You didn't type in anything. GitHub Copilot is acting as a proxy for you, using the GPT models of OpenAI behind the scenes on your behalf. So essentially it says active selection from file index.js, and this is exactly what I selected. Can you remember? This is what I selected in VSCode. And then the next content is, can you complete this method for me? Can you remember where this came from? This is exactly the prompt that I specified here in GitHub chat. Okay? So this is appended to the request. Now this is also an interesting one. If you have asked yourself which modal GitHub Copilot uses behind the scenes, now maybe you know it. I don't have access to the source code. I can't tell you if they ignore this setting and use a different modal behind the scenes. I can't answer this question, but at least it is somewhat interesting for me what they sent here. By the way, with MITM Proxy, you can intercept requests and rewrite them before they are sent to the server. So you can write the Python script and play around with these requests. You can even export here, something like this. You can export a curl version of this request, and then you can rerun this curl request and try to change it. But don't get your hopes too high. The proxy is really secure, so if you request something that it doesn't want to support, you will get an error message. So this stuff is really hardened, it's secure, don't worry. So if you play around too much, don't be angry with me if you are thrown out of GitHub Copilot. So do that on your own risk. I'm not telling you to do that, but I'm just telling you you could. So if you think, oh, I'm super smart and I'm just specifying here not 4096 max tokens, but 128k tokens, and you think that GitHub Copilot, that you can fool GitHub Copilot proxy, probably you can't. Okay, so yeah. But I think it's kind of interesting that we see that GitHub Copilot chat works completely different from code completion, right? Okay, very good. So let's go back to our small little sample, and I think you all know that I could, without any problems, create this code. Oops, sorry. So I will simply copy it in. Oops. Yeah. Okay, that is interesting. Now, what's going to happen, and that is my last demo, and then we'll wrap up. Jürgen, am I still good on time? 10 minutes?
Yes.
Good, very good. Good. First, let's try if this stuff really works. Ah, it looks good. Yeah, I can mark it, I can click on it, and I won. That is good. Maybe with 3 bombs, it's not very... Oh, my God! 3 bombs! 3 bombs! And I managed to click on one of them. Isn't that great? So, yeah, the code works. But imagine that you would like to, I don't know, create a little bit of unit tests, for instance. So let's take a look at that one. Execute for surrounding cells looks good. And here on the left-hand side, I simply say /tests. You maybe have already seen these / commands. There are multiple / commands like explain and docs and test. I don't want to bore you, so please read the documentation if you want to know what they do. Essentially here, I'm just using /workspace /tests, and I'm going to say jest. Jest is a unit testing framework for JavaScript, for those of you who are no JavaScript developers in the room. So let me clean up the proxy. Here we are. and run this request. I always tell myself I need to prepare jokes for this situation, but I'm very bad in. Sometimes in these situations, I open up ChatGPT and ask it, tell me a joke about JavaScript. But last time I did that on stage, the joke was so bad. It was so bad that I stopped doing that. Well, if you stand on stage and something like that happens, people still laugh, even if the joke is bad. But yeah. Okay, it's not interesting what it does. I mean, the response is meaningful. It's perfectly fine. But we are interested in the request. And this time, of course, we are going to export everything again. Raw request, requests. And this is the sample 4, I think. Good. Let's go here. We are a sample 4. Let's remove this stuff. Let's replace all these things. And let's take a look. This is the answer that was generated. To generate tests for your code using Jest will follow the following steps. See that? And that's essentially what you see here. But the question is, why is the answer that was generated by GitHub Copilot part of the request? Because GitHub Copilot does something which is kind of interesting. We have 2 requests. This was the first request that you see here. And in this case, you see what I marked, and somewhere, blah, 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 it's going to generate some test. This was the last step with the user. And then we have a second request to the completion. So one question to the GitHub Copilot chat resulted in 2 requests. Why? The answer can be found at the very end. Write a short 1-sentence question that the user can ask that naturally follows from the previous request. So what they are doing is they are using OpenAI behind the scenes to suggest the next questions that the user might ask. And that was kind of interesting for me to see. So they take the request that I did, they suggest something, then they take everything I wrote, take everything the assistant wrote, send everything again to ChatGPT and say, hey ChatGPT, what could the user ask next? So they are using ChatGPT 2 times for a single request in order to support you, or in order to, let's put it like that, keep the conversation going. See? So this is what Gerald meant when he said this thing is pretty smart in prompt engineering, because it writes the prompt for you. And this demo should show you that this is not trivial. There is a lot of know-how in the prompt. Of course, most of the know-how is in the infrastructure and the LLM, but still using these things to drive the whole user interface is kind of interesting. My goal for this session was to show you a little bit behind the scenes what's really going on the wire, and to show you that they are really just using traditional prompt engineering techniques from OpenAI. I hope that was interesting. I also find these experiments always very interesting because a large part of my job in the last 2 years has become to either write OpenAI-based chatbots on my own for my own company, or to help customer to be successful with OpenAI and the OpenAI API. And it's always very interesting to see how super smart developers in companies like GitHub use the OpenAI API, how they write prompts, so my chatbots will become smarter and better. And this was the reason why I suggested this session. I hope you enjoyed it. I hope you liked my demos. I hope the recording worked. And with that, we can open it up for questions. Thank you very much.